Have you ever wondered how the chirping of birds, the roar of a lion, or the melodious notes of music reach your ears? The answer lies in the fascinating world of sound. It's the invisible force that shapes our interactions and experiences, yet it often goes unnoticed. Sound is much more than just noise. It's a form of energy that moves in waves, invisible to the naked eye but powerful enough to travel vast distances. These waves are born from vibrations, the rapid back and forth movements of any object. When something vibrates, it sets the surrounding air particles in motion, creating a chain reaction that propagates these waves. This journey from the source of the vibration to our ears is what we perceive as sound. This is just a glimpse into the intriguing universe of sound, so buckle up and get ready to be amazed by the invisible waves that surround us. Sound is born when something vibrates, setting the surrounding air particles in motion. Such a simple act of vibration, yet it initiates a remarkable journey that ends in the familiar sounds we hear every day. Let's delve into the concept of vibration. Imagine plucking a guitar string. As it moves back and forth rapidly, it causes the air particles around it to also move. This movement of air particles is what we call vibration, but it doesn't stop there. As one particle moves, it bumps into its neighbor, causing that particle to move as well. This motion continues, with each particle influencing the next, like dominoes falling in a line. It's a fascinating chain reaction, a dance of particles choreographed by the original vibration. This chain of moving particles creates waves in the air, waves that carry energy away from the source of the vibration. And when these waves reach our ears, they vibrate our eardrums. This chain reaction is what we hear as sound. Sound waves travel outwards from the source in all directions. This is a simple statement, yet it holds the key to understanding how sound journeys through space. So let's dive a little deeper into this fascinating process. Imagine a pebble being dropped into a calm pond. The pebble disturbs the water, creating ripples that move outwards in circles. This is similar to how sound travels. When an object vibrates, it disturbs the air molecules around it, creating waves of sound that move outward in all directions. But here's where things get really interesting. Sound doesn't only travel through air, it can also journey through other mediums like water and solids. Picture a submarine deep in the ocean. When it sends out a sonar signal, that sound travels through the water at a speed much faster than it would in air. This brings us to an important point. The speed of sound varies depending on the medium it's traveling through. In air, at room temperature, sound whizzes along at about 343 meters per second. But in water, it's a different story. Sound speeds up, traveling at a whopping 1,483 meters per second. That's about 4 times faster. And in steel, sound travels even faster, reaching a staggering 5,100 meters per second. So how does all this sound get to our ears? Here's the step-by-step rundown. First, an object vibrates, setting off a chain reaction of compressions and rarefactions in the surrounding air molecules. These create a sound wave that travels through the air, or water, or solid, until it reaches our ears. When the sound wave arrives, it vibrates our eardrums. This vibration is then transmitted to the tiny bones in our middle ear, which amplify the sound and pass it on to our inner ear. Here, hair cells convert the vibrations into electrical signals which are sent to our brain. And voila! Our brain interprets these signals as sound. So next time you're listening to your favorite song or the soothing sounds of nature, take a moment to appreciate the incredible journey that sound has taken to reach your ears. When the sound wave reaches our ears, it vibrates the eardrum. The vibrations are transmitted to the brain, which interprets them as sound. Sound isn't just about being heard. It has various scientific features that make it unique. Let's take a closer look at some of these properties: speed, pitch, loudness, and timbre. First off, the speed of sound. This is the pace at which sound waves travel from the source to our ears. In general, at room temperature, sound zips through the air at around 343 meters per second. Quite speedy, isn't it? But the sound doesn't always maintain this speed. It changes based on the medium it's traveling through. For instance, if sound is traveling through water instead of air, it picks up the pace and moves a lot faster. Moving on to pitch. This is the feature of sound that determines whether it's high or low. The pitch is directly related to the frequency of the sound wave. Higher frequency waves result in high-pitched sounds, like the squeak of a mouse. On the other hand, low-frequency waves create low-pitched sounds like the roar of a lion. Next up is loudness. This is all about how strong or weak a sound appears to us. The loudness of a sound depends on the amplitude of the sound wave. High-amplitude waves produce louder sounds. So the booming sound of a drum has a higher amplitude than the quiet rustle of leaves. Lastly, we have timbre. This is what gives a sound its unique quality. It's the reason why a guitar and a piano playing the same note sound different. Timbre depends on the mix of frequencies in the sound wave. Each sound we hear has a complex mix of different frequencies, and this mix results in the unique timbre of the sound. So when we listen to sounds, we're not just hearing noise, we're experiencing waves with unique speeds, pitches, loudness, and timbres. It's these properties that allow us to distinguish a whisper from a shout, a violin from a flute, or a cat's meow from a dog's bark. The pitch, loudness, and timbre of a sound are determined by the properties of the sound wave. So there you have it. We have explored the fascinating world of sound. We've journeyed from understanding that sound is a form of energy that zips through matter in waves, to how these waves are born from vibrations. We've learned that these sound waves don't discriminate. They travel in all directions from the source through air, water, and even solids. Remember though, the speed of sound is a bit of a diva. It changes depending on the medium it's traveling through. We've also dipped our toes into the scientific properties of sound. The speed of sound, for instance, is around 343 meters per second in air at room temperature. And did you know that the pitch, loudness, and timbre of a sound are all determined by the properties of the sound wave? Remember, sound is a form of energy that travels in waves, and the pitch, loudness, and timbre of a sound are determined by the properties of the sound wave. Now go explore the world of sound around you.